Imagine a seemingly insignificant grain of sand, a tiny speck of matter we barely notice on a beach. Now picture this grain hurtling through the vastness of space at the fastest speed imaginable, the speed of light. What would happen if this minuscule projectile were to collide with our planet? This thought experiment, while improbable, offers a glimpse into the incredible forces at play in our universe. It allows us to explore the fundamental laws of physics and the sheer power of energy. While the scenario might seem like something out of science fiction, it serves as a reminder of the awesome and sometimes terrifying potential of the cosmos. So, let's dive in and explore the hypothetical consequences of a grain of sand hitting Earth at the speed of light. First, let's grasp the sheer speed we're talking about. Light travels at approximately 299,792,458 meters per second. That's roughly 186,282 miles per second. It's so fast that a beam of light could circle the Earth over 7 times in a single second. To put it into perspective, imagine you could travel at the speed of light. You could travel from New York to Los Angeles in the blink of an eye, literally. In fact, you could travel around the Earth's equator over 7 times in 1 second. That's the mind-boggling speed we're dealing with when we talk about light. It's the universe's ultimate speed limit, and nothing we know of can travel faster. Now, imagine a tiny grain of sand, carrying all its mass, moving at that speed. It's a recipe for an astronomical event of unimaginable proportions. The energy carried by an object in motion is known as kinetic energy. The faster an object moves, the more kinetic energy it possesses. Einstein's famous equation, EM2, reveals the immense energy contained within even the tiniest amounts of matter. In this equation, E represents energy, M represents mass, and C is the speed of light. Since the speed of light is such a massive number, even a tiny amount of mass, like that of a grain of sand, multiplied by C2, results in an astronomical amount of energy. It tells us that mass and energy are interchangeable, two sides of the same coin. This equation is most famously associated with nuclear weapons, where a small amount of mass is converted into a tremendous amount of energy. Now imagine that energy unleashed by a grain of sand traveling at the speed of light. It's a number so large it's hard to comprehend. Let's envision the grain of sand hitting the Earth's ocean, which covers over 70% of our planet's surface. The impact would be nothing short of catastrophic. The immense kinetic energy would be released instantly upon impact, vaporizing a massive column of water and creating a shockwave that would radiate outwards at supersonic speeds. This shockwave would be far more powerful than any earthquake or tsunami humanity has ever experienced. Coastal cities would be completely obliterated, wiped off the map within minutes of the impact. The ocean floor would be carved out for miles around the impact site, creating an underwater canyon of unimaginable proportions. The devastation wouldn't stop there. The shockwave would continue to travel through the planet's interior, triggering earthquakes and volcanic eruptions on a global scale. Section 5. Land impact. A crater of immense proportions. If the grain of sand were to strike land, the results would be equally devastating. The impact would release its energy in a fraction of a second, creating an explosion that would dwarf the largest nuclear detonation ever witnessed. A crater miles wide and hundreds of miles deep would be carved into the Earth's crust, instantly vaporizing everything within a vast radius. The intense heat generated by the impact would ignite wildfires that would rage across continents. Millions of tons of rock, soil, and vaporized material would be ejected into the atmosphere, blanketing the planet in a thick cloud of debris. The dust and debris would block out the sun, plunging the Earth into a state of perpetual darkness. Without sunlight, global temperatures would plummet, leading to a catastrophic ice age. Life as we know it would cease to exist. Section 6. Global consequences. A world transformed. The effects of the impact wouldn't be limited to the immediate vicinity. The shockwave from the impact would travel through the Earth's atmosphere at incredible speeds, creating hurricane-force winds and sonic booms that would circle the globe multiple times. These winds would be strong enough to level forests, flatten buildings, and scatter debris across vast distances. The massive amount of energy released by the impact would also disrupt Earth's magnetic field, leaving us vulnerable to harmful radiation from the sun. Our atmosphere, our shield against the harshness of space, would be severely compromised. The impact would be a global extinction-level event. wiping out not just human civilization but a significant portion of life on Earth. It's a sobering reminder of the delicate balance that sustains life on our planet and the awesome power of the universe we inhabit. Section 7. The impossibility of light-speed grains. While the scenario we've been discussing is terrifying in its implications, it's important to remember that it's essentially impossible based on our current understanding of physics. According to Einstein's theory of relativity, as an object approaches the speed of light, its mass increases infinitely. This means that it would take an infinite amount of energy to accelerate even a tiny grain of sand to the speed of light. In essence, the laws of physics as we understand them prevent objects with mass from reaching the speed of light. The universe, it seems, has a built-in speed limit. While this might be disappointing to science fiction enthusiasts, it's also reassuring. It means we don't have to worry about light-speed grains of sand, or any other macroscopic objects for that matter, posing an existential threat to our planet. Section 8. The Universe, a realm of astonishing power. Even though our thought experiment is firmly in the realm of the impossible, it highlights the immense energies that exist in our universe. From the nuclear fusion powering the stars to the gravitational pull of black holes, the cosmos is a realm of forces that dwarf our everyday experience. While these forces can be destructive, they also drive the creation of stars, planets, and even life itself. It's a reminder that we are part of something much larger than ourselves, a universe full of wonder, mystery, and incredible power. It's a universe ripe for exploration and discovery, and it's up to us, the curious inhabitants of this pale blue dot, to continue to unravel its secrets. Section 9. Keep looking up. So the next time you're at the beach, take a moment to appreciate the humble grain of sand. It might seem insignificant, but it holds within it the secrets of the universe's incredible energies. And while we may never see a grain of sand reach the speed of light, the very thought of it is a testament to the power of human imagination and our endless fascination with the cosmos. Keep looking up at the stars, keep asking questions, and never lose your sense of wonder. The universe is full of incredible things just waiting to be discovered. Thank you for joining us on this journey through an extraordinary hypothetical scenario. If you enjoyed this exploration, be sure to like, subscribe, and hit the bell icon for more intriguing content about our universe. Let your curiosity guide you to the stars. Until next time, keep wondering and keep exploring.